This is the third video for Math 107, sample exam number 1. For these two problems, well, for the first problem, we're concerned with the composition of functions. This is a new operation for functions, as you know. The other operations you're familiar with from arithmetic, which would be addition, subtraction, multiplication, and division of functions. But here, this new operation is composition, and the way to think about it, I'm going to write through this, is going to be f composed with g. Some people like to say fog, but then don't bother with that. Just say f composed with g. The next step, you say f, the first one, is the outside function. The second one, whatever its name, is the inside function. Okay, you should mechanically be able to do that, even though you may be struggling with the concept of composition. You can be able to do the mechanics. First one goes here, second one goes here. Then look up here and see what the second one is and put that in. So that's x squared minus 9. Alright? So I substituted that right there. Now I use function evaluation. That means every place there's an x in the f function, or the outside function, here's one here and here's one here, I have to substitute x squared minus 9. So I will do that, but I'm going to have to make some room for myself and go all the way down here. So I have 3 x squared minus 9 minus 5 over x squared minus 9. Alright, obviously you're going to have a little change in domain here, but let's just leave it at that. Sometimes you work through this arithmetic if there's a way to simplify, but here there is not a way to simplify, so you can leave it in this form. Important points. F composed with g. The first one, in this case f, is the outside function. The second one becomes the inside function. Once you've written that, go up and find out what the inside function was and put it in the parentheses. Then go back to your original function for f, and every place there's an x, you put this. That's the mechanics of composition. The next is another domain question. So how do you figure out the domain? First you say it's all real numbers, and then you say, is there any chance to divide by 0? In this case, for f, there sure is, because here's an x in the denominator. If there's no x in the denominator, there's no chance. But here there is. And what value can x not have? It better not be 0. This one's pretty simple, no factoring involved. Now let's try to write that in a decent way. The domain of f. Okay, in set builder notation, you would say it's a set of all x's in the real numbers, in the set of all real numbers, such that x is not equal to 0. Alright? That's one way to write it. The other is to write it like this, the interval way. So I don't want 0. That means I start at negative infinity and I go all the way to 0, but I don't include it. That's what the parentheses is. Jump over 0, and now I can go to infinity. Now we have again the concept of symmetry, but this will be with a function, and it's not algebraic, it's looking at the graph and determining whether it's an even, odd, or neither function and why. And here's the function you're supposed to look at and figure it out. Now, if it's an even function, that means you could draw, I'll do an even function for you here. So let's say we have a parabola like this. Well, if somebody could draw, there, they bought me this important graphing tablet and I still can't do anything. Alright, that's so pitiful. Let me see if I can't do something about it. Okay, let's try it again. Alright, here is my function. Now the idea here is that if I drew that line down the y-axis, which right on top of the y-axis, it would be the same on this side as this side. If I fold it over, they would lie right on top of each other. Another way to think of it is that they're reflections of each other. It's like it's a little complicated to think like that. So this is an even function. For an odd function is demonstrated here. This may or may not be the one on the test. It's it's considered to be symmetric about the origin. You can think that you would have flipped it over the y-axis, flipped it over here, and then flipped it one more time. That's one way to think about it. I kind of think of it like that, but there's another way too. Okay, so let's say I just had this piece like this, and the first thing I did was flip it about the y-axis. Well, it's going to look like that, right, if I just flip it about. But then I make one more. I take what's up here and put it down, and what's down and put it up, and so I end up with this. And now you can see that is an odd function. The other way to think about it is it's symmetric about the origin. If you put a thumbtack right in the origin and twirled it in the plane, you would end up with this function. Okay, so this is odd. This is the last question on the test, and the actual question on the test will have much more information than this in it, although the calculation isn't any harder. It just requires you to read the question. One technique that's used sometimes to teach people how to do application or so-called word problems is this. So this is kind of a silly little song, and it goes to the Addams Family song, and I won't sing it for you, but you can figure it out. Here's how you do it. You say, underline the question. So I'm going to underline the question. And the question is, what is the writing speed in kilobytes per second? There we go, that's the question. Circle information, right? Here is 52 times the transfer rate, and here is the transfer rate. If there is a lot of extra information on the page, this really helps. Then you pick an operation. Well, it's 52 times faster than something. The operation is going to be multiplication. And then you just, and a strategy. The strategy is just to multiply, and that's shown here. The CD burner burns CDs 52 times faster than the original transfer rate. The original transfer rate is 150 kilobytes per second. What is the writing speed in kilobytes per second? Well, I would just take 52 times 150 and get whatever I get out. In this case, 7600, and nothing changed. So this is still kilobytes per second. It's good to write some units down. Okay. Since I didn't change anything, the unit stayed the same. All I did was multiply it by 52. Right. The next is, what's the writing speed in megabytes per second? Right. Now there's several ways you can do it. One way is to go back and remember that kilo was 10 to the third, mega is 10 to the sixth. So I can change all the way back to bytes. 1600 kilobytes is 1600 times 10 to the third, because kilo means 10 to the third. Right? And I could even multiply all that out. Now if I want to go to something with 10 to the sixth, I have to move the decimal point 6 over, and I get 7.8. You don't have to do all these steps. If you can figure it out in your head, which you actually should be able to do. I have 7600 kilobytes per second, and I know that is 10 to the third, and meg is 10 to the sixth. That means I've got to move that decimal point over 3 more to get from 3 to 6, so that's 7.6 megabytes per second. And that's the test.